Okay, we're doing a second day of angle relationships, proving them. And we're going to try to successfully write proofs involving complementary and supplementary, congruent, right angles, vertical angles, all kinds of stuff. I just want you to realize that reflexive property of congruence, the symmetric property, and the transitive property all hold true for angles, not just the segments and stuff that we've talked about. So we might be using those today within the proofs on angles. So first thing we're going to do is prove the right angle congruence theorem. All right angles are congruent. That's what it says. So what they did here is they've got angle 1 and 2 are right angles. There's your little picture of them. And that was given to us. Then the measure of angle 1 is 90 and the measure of angle 2 is 90 because that's the definition of a right angle. Next, the measure of angle 1 equals the measure of angle 2 by transitive property because it says angle 1 equals 90, angle 2 equals 90, therefore angle 1 equals angle 2. Now, I would also have accepted a different answer on that line. What else did you think it might have been? Substitution. Okay, so I would have taken that also. All right, and then angle 1 is congruent by definition of congruent angles. And if you want to abbreviate that, guys, certainly feel free to write it a little more simplified, like definition of, and then a congruent symbol, and then the angle symbol. That's fine. We just proved that all right angles are congruent. So now maybe we'll use it. This symbol has somehow, and this word that this symbol represents, has been one of the ones that people do not know. An upside down capital T means perpendicular. But then, even if you know the word perpendicular, you got to know what perpendicular means, which means forms right angles. Okay? If you've been having struggles with your vocab, one idea is to make flashcards. And, you know, that's just a good way to help you get things memorized. So, the statement here is just what was given. So our first thing is given. It says that JK is perpendicular to KL and ML is perpendicular to KL. Therefore, by definition of perpendicular lines, the measure of angle 1 would be 90 and the measure of angle 2 would be 90 in the diagram. Now, I'm not always fond of the 1 and the 2 thing. You do have that on your picture? So what if you didn't have that on your picture? You would have had to write JKL for angle 1. That's the same thing. MLK would have been angle 2. So you need to know how to write it with 3 letters anyway. So let's go ahead and do that. So we got definition of perpendicular lines. Now, then here it would have been the same replacements for them. If you have the measure of angle 1 is 90, the measure of angle 2 is 90, the measure of angle JKL is 90, and the measure of angle MLK is 90, then angle JKL is congruent to angle MLK, and that would be by transitive property or, oh no, we're going to use all right angles are congruent. Since both of these were 90, we can use the fact that we just proved that all right angles are congruent, which is the right angles congruent theorem. You can just write what it says. All right angles are congruent. That would be absolutely fine with me. And usually I allow my students to do an abbreviation of that, which would be all right angles congruent. And that would be fine. Okay, now we need to talk about, and some bright colors here, the congruent supplements theorem. The congruence, it says if 2 angles are supplementary to the same angle or to congruent angles, then they are congruent. You need to fill in the word congruent. Here's what it's really saying. If you look over this diagram, angle 1 and angle 2 are supplementary. Angle 2 is supplementary with angle 3, therefore angle 1 and 3 must be the same size. They have to be congruent. That's all it says. The congruent complements theorem is much the same. Oh, did you guys not have this? You had to put this in your blank too? So if angle 1 and 2 are supplementary and 3 and 2 are supplementary, then angle 1 is congruent to angle 2. And we're going to do an abbreviation through this. Be by congruent sup theorem is how I'm going to let you abbreviate it. There's also a congruent complements theorem that says basically the same thing, except it's about complementary angles instead of supplementary angles. You got to know your words. If two angles are complementary, meaning they add up to 90, if they're complementary to the same angle or to congruent angles, they have to be congruent also. So I'm going to write over this in red so you can actually see it. And all that one's saying is that if angle 4 and 5 are complementary and 5 and 6 are complementary, that means 4 and 6 have to be the same size. That means angle 4 is congruent to angle 6. All good? Oh. Thank you. We have talked about the linear pair repeatedly. If two angles form a linear pair, then they are supplementary. If angle 1 and 2 form a linear pair, since angle 1 and 2 do form a linear pair, angle 1 plus angle 2 add up to 180. That's the supplements theorem, when you get to say that. Theorem 2.8 is the vertical angles congruent theorem. All vertical angles are congruent. Well, no, it's vertical angles are congruent because you have to look at each individual situation. In this case, angle 1 is congruent to angle 3, and 2 is congruent to 4. So vertical angles are congruent. Need to know that. So that's what the vertical angles theorem says. So now we're going to try a few proofs. Oh, these are other right angle theorems. Kind of obvious ones. Perpendicular lines, we already know, intersect to form 4 right angles. They're saying perpendicular lines, so they mean lines that intersect at a right angle. My pen went crazy. There we go. So these would be an example. This would be an example of perpendicular lines, and you would have 4 right angles. Perpendicular lines form congruent right angles. Well, come on. If they form right angles and all right angles are congruent, this is kind of redundant of that. Okay. If two angles are congruent and supplementary, then they are right angles. The only way for that to be possible is if two angles are supplementary and they're the same size, they would both have to be 90. And if two congruent angles form a linear pair, then they're both right angles. That would look like this, where the last one, they don't have to be a linear pair. This one is saying they are. So none of this is that really hard. We're not really going to formally write these by the numbers at all into our proofs. We'll just say things. Okay, so I'd like you to try this one with me, and maybe you can give me some help with it. It says angle 1 and angle 2 are supplements, and angle 3 and 4 are supplements. This is going to be a very fast proof. It was given. Angle 1 and 2 are supplementary. They form a linear pair. Angle 3 and 4 are supplementary. They form a linear pair. it says that what would the congruent supplement theorem tell us? Well, if angle 1 and 2 are supplements, there's a typo here. Does your paper have the typo on it? Do you have a 3 here? You have a 1, so mine's got the typo, right? This should be a 1. Now, because otherwise I couldn't even use the congruent supplements theorem. It wouldn't even make sense. Angle 1 and 2 are supplements. Angle 1 and 4 are supplements. Therefore, angle 2 is congruent to angle 4. That better be what it says. Yes. Angle 2 is congruent to angle 4 by the congruent supplements theorem. The measures would be equal because that's the definition of congruent angles. Remember, you can write these a little bit abbreviated. Okay, and then finally, the measure of angle 2 is 45 was another thing that had been given. And then you could put in that angle 4 is also 45 by substitution. Okay, not too bad, I hope. So next we have that angle 4 is a right angle. It's given. Okay, then we're going to probably be writing down that angle 2 is the measure of angle 4 is 90, and that would be because the definition of a right angle. You don't have this one, do you? Oh, we must have taken it out. Sorry, I'll just skip to what you do have right here. What are you going to do to find angles 1 and 2? Ideas? It says measure of angle 4 is 63. Why? Okay, so if you were trying to tell me why the bivertical angles are congruent, you could say angle 2 is 63 degrees. Did you have another idea? I think you're going to say something, Cadence. What were you going to say? Because you're calculating. What were you going to do? Oh, that is a good plan. He said he was going to take angles 2 and 4 that are both 63, add them, subtract from 360, and divide by 2 because these are equal. Well, why are 1 and 3 equal? They're also verticals, right? They don't have to go up and down like a V. Okay, so he's got a good plan, but there's another plan we could use with the theorem that we had today. Okay, because why? Okay, they're supplementary. So by the supplements theorem, you could do 180 minus 63 to get angle 1 or angle 3, right? So that might just be a little bit shorter, Cadence, but your plan, it works just fine. Okay, so what are those, guys? What's the measure of angle? 180 minus, oh, so that's the measure of angle 1, 117. And then the measure of angle 3 is also 117. Now, you didn't have to write all of that out. I just was just giving ideas. How, if you were doing a proof, what you could say. All right, then in part B, it's changed everything on me. It changed the it changed the numbers. So now we have a whole different situation because they chose to make angle 3 121 now. All right, so angle 1, I would go for that one next because it's going to be this vertical to it, so it'd be 121. What would the measure of angle 2 be, which is the same as the measure of angle 4? Find it. At 59? Come on, you guys, do you have calculators? Yeah. Does everybody understand why they're both 59? Now just changing the numbers. We are not measuring, so you have to go with the numbers they're giving you. It's not like we're taking a protractor and doing it. It's different. What stuff? Okay, example 5. It says, write and solve an equation to find x. Well, what's the equation we're going to use for this one? And I'm going to call on somebody to help me. Tyler? Well, what do you know about these angles? Were you not listening on this one? Like these are vertical, so these are also vertical angles. Okay, these angles are vertical angles. They are congruent. So you would set 4x minus 18 equal to 3x plus 4 and solve it. Subtract 3x from both sides. Add 18 to both sides. Plug it back in. To get the measure of angle AEB, you will need to do 4 times 22 minus 18. You guys finish that one off, please. Okay, you're going to be finishing the rest of this, at least those problems on that page. I think let's go to the back, please. All right, let's start the proof. We should go ahead and put all the givens in line 1. Angle 1 and angle 2 form an LP, linear pair. The measure of angle 3 plus the measure of angle 1 equals 180. These were all given. Okay, if angle 1 and angle 4 form a linear pair, what do you know about them? What, Kenny? They're supplementary. Angle 1 and angle 4 are supplementary. That's by the supplements theorem. That's what it says. If you have a linear pair, then they're supplementary. They already gave us measure of angle 3 plus the measure of angle 1 is 180, so those are also supplementary. Measure of angle 3, or let's just do angle 1 first. Measure of angle 1 and the measure of angle, I forgot to put the M's on these. Oh no, I didn't have to put the M's on those, excuse me. It says angle, I don't even have to have M's on these. What am I doing that for? Angle 1 and angle 3 are supplementary. That's all we need to write. Okay, and that's by definition of supplementary because they already said that they add up to 180. So that's the definition of supplementary angles. All right, if 1 and 4 are supplementary and 1 and 3 are supplementary, then angle 3 is congruent to angle 4 by the congruent supplements theorem. That if two angles are congruent to, two angles are supplementary and another pair of angles are supplementary. If one of them matches, the other two have to be congruent. Okay, now we're going to have to do one probably that has to do with complements. And it does. It says that AB is perpendicular to BC. That's given. And then we'll put in the next given, angle 1 and angle 3. I don't know why sometimes they decide to put them all on one line and sometimes they don't. Oops, are congruent. They're not congruent, they're complementary. COMP. Now, if, let's see, we got AB is perpendicular to BC. I want to use definition of perpendicular, so I must be wanting to say what that tells me. If segment AB is perpendicular to segment BC, then we've got a right angle, and it's called angle ABC. Yeah. All right, so that would tell me that angle ABC is a right angle. Because the next line is telling us that angle ABC is 90 then, by definition of a right angle. So if it says definition of a right angle, you've got to actually write something about a right angle in the previous statement. Okay, well, that's already done for us, the next line. Now it says the measure of angle ABC equals angle 1 plus angle 2. How come? We haven't written that one down for a little while. Why is this angle equal to angle 1 plus angle 2? What are you doing right here? You're adding, right? What are you doing? You're adding two angles to get a bigger angle. I'm hearing it. Angle. What are you doing with the angles? Addition postulate. Just like segment addition postulate, if you add two angles, you're doing angle addition postulate. Okay, now, you see this line? D and E. I'm going to show you where this is coming from. They're taking that they said in D that measure of angle ABC is 90, and they're sticking that here to make this line. What did they do? Made a substitution. That's why it says substitution here. So I know it was there already, but I want you to know why that line was there, okay? They took this, put it there, made a new line, and did it by substitution. Now, it says angle 1 and 2 are complementary. Well, what do complementary angles do? They add up to 90, so that's definition of complementary. Definition of complementary angles. Even if you didn't write angles, it'd be fine. That's what definition of it is. Two angles whose sum is 90. And then finally, angle 2 is congruent to angle 3 by, now here's the hard one to know why this is this one. You got to look at line B, which says angle 1 and 3 are complementary. And you have to look at angle G, line G that says angle 1 and 2 are complementary. If 1 and 3 are complementary and 1 and 2 are complementary, then 2 and 3 are congruent by the congruent complements theorem. Those two made the next line. Okay, so these next questions here, finish this page, please. I also would like, there's only like a few questions on there. Yes, Bryce? Sure. Right here? The other thing I thought we would do is maybe look at a couple of proofs from Wednesday in our 2.8 packet that you'd like me to go over, maybe. Oops, he's still looking at that just a minute. Okay, thank you. That's not, we want this. Okay. Nope, that's not it. On your page 2, or not, like after the notes we did on Wednesday, doesn't it say practice on 2.8 proofs and review? Pretty big, actually. I did not plan on doing all of the problems there, but I wanted to help you with some of it. This is that one. Again, these are the pages in the packet, 2.8, and it was a big packet. Okay, it had quite a bit of practice listed there. I'm hoping that you could do more of it now. Maybe you're not understanding what it says to say to name the theorems that justify your work. So maybe I'll help out with a few of those. Maybe even based on today, maybe you would even know better. What are these? Why are they supplementary? Because why do they add up to 180? Wait a minute. So I'm trying to go back further. They're a linear pair, therefore they're supplementary, and they add up to 180 because they're supplementary. Okay, so I know what you would do quickly. You'd probably just grab your calculator and go 180 minus 57, right? So all I want to do is I want to see is your answer for the measure of angle 1. What they're asking for you is name the theorem or theorems that you justified your answer. This is the supplements theorem because they're a linear pair, they're supplementary. Okay, and supplementary angles add up to 180. So I think that's good enough just to say the supplements theorem. What kind of angles are 5 and 6? They're complementary. So let's use the complements theorem for that one. So I know what you're going to do. You need to find me the measure of angle 6. You're just going to use your calculator. I'm not going to write down these answers. I think you could have done this. What are you going to use for a reason on 3? How did you decide what to do? Come on, just stay with me because you need to go back and do a little bit of homework. I know most of you didn't do any of this probably, or not much of it. Yeah, what are these though? So they're asking you to give a theorem, the vertical angles theorem. Its vertical angles are congruent is what it says. And then back to here, you're going to add these up to say that they equal 180. And then you're going to give the measure of angle 13 and the measure of angle 14. All right, they add up to 180 because of the supplements theorem. Okay, so we'll just say 7x plus 12 equals 180. I already added them like terms. And you finish solving. Okay, let's do a little bit more on the proof together. This is a little bit trickier, but you're going to use 2 theorems on number 5. You're going to use the complements theorem. Because if 9 and 10 are complementary, then so are 7 and 8. And the congruent complements theorem. Well, what do you mean, Heimer? Well, it said 9 and 10 are complementary. 7 and 8 are going to be complementary then too. But it also says that the measure of angle 7 is congruent to the measure of angle 7 and 9 are equal. So if 7 and 9 are equal, then 8 and 10 have to be equal as well. So if 8's 41, 10's got to be, yep. And then since these are complementary, we're just going to do 90 minus 41 and get the rest. Well, that's going to be 59? No, 49. Guess that was enough. And here we're going to use the vertical angles theorem. and set them equal. 4x minus 26 equals 3x plus 4. That's all I'm going to let you finish solving those. Okay, let's do number 7. I want to see if you can help me here, though. Angle QPS. Oh, I keep making R's instead of S's today. I mean, instead of P's. I don't know what's going on with that. RPS is congruent to angle TPR. I think it's because there's P's and R's in here. I don't know what it is. Well, anyway, that was given. Okay, now, why would they be equal then? If their angles are congruent, then the measures are equal by definition of congruent angles. Okay, please look at the next line and think about what the reason would be. Bryce, the line's not up there, over there. It's over here on the paper. Come on, guys. Look at this. Read this. See if you understand what's going on. Please. All this says is that plus, okay. The other one says PPR equals PPS plus SPR. What are they doing? They're adding angles, right? What allows you to add 2 angles to get a bigger one? Angle addition postulate, guys. All right, well, if they already have in line, this is really not that bad of a proof. You already have that angle QPS equals angle TPR right here. So let's take this, put it in there, and take this and replace it for that. It's going to be a long thing to write, but what we're going to write is the measure of angle QPR plus the measure of angle RPS equals the measure of angle TPS plus the measure of angle RPS. By substitution. We made a substitution. Plop that in there, pop this in that, and then make a new line. Do you see something we could do to that equation now that'll get us to where we're headed? Do you see anything matching? Guys, gotta look for something to do next. Look. Yeah, those match on both sides. So let's get rid of it. If we subtract RPS from both sides, the measure of angle RPS, we're going to be using the subtraction property. If we subtract that from both sides, we're going to have the measure of angle QPR equals the measure of angle TPS. And that's what we were trying to prove, is that angle QPR is congruent to angle TPS. And that is by definition of congruent angles. Okay, we're going to try one more together. Anybody need this still? I don't mind. And if anybody needs me to print it, just tell me, I'll print. I've been having a horrible time with vocabulary for some of us. I'm getting to where I'm like thinking maybe some people should use some flashcards or something. I've mentioned that already. Because this word's been a real, I don't know why this one's so hard, but it always is. It's always like a lot of people still forget what that's telling us. I know you know by means to, right? What is, and maybe I gotta break this word up. If you dissect something, what do you do? What do you gotta do to take it apart? Usually, if say it was an animal, you gotta cut it, right? So instead of dissecting it, we're gonna bisect it. So what do you think that might mean to do to it? Yeah, but let's make them equal, okay? So bisect means it's cutting it in half, all right? So that's cut in half. You have to know what that word means. Got to learn it. It's not going away. So to bisect something, this ray is ray BD. And it's taken and it's cutting angle ABC in half. What does that mean has happened? What has happened then if that ray chopped that angle in half? So angle 1 is congruent to angle 2. That's what it does. So I like to just get that out of the way for a minute here and let's think about it. Okay, so we're going to put this in our proof. I mean, I know geometry can be very dry and it's not the most exciting thing. I'm trying. It's really, some parts of it are kind of interesting and so we'll grab some people, but we got to still try to get through it. So it says ray BD bisects angle ABC. And proofs are not people's favorite. I know. I'm just trying to at least make them doable for you. All right. So it was given to us. So see this word, it says a hint. Definition of angle bisector. We should say something about what we just talked about. What should we put next, do you think? Angle 1 is congruent to angle 2. All right, let's do that. Which I could write angle ABD is congruent to angle DBC. Well, if you prefer to write angle 1 is congruent to angle 2, that's totally fine. All right, let's just go with angle 1 congruent to angle 2. So what's the definition of congruent angles leading me to do? It's giving you a hint here. You should be able to write what goes here. If you go from congruent, you're going to add on the little m's, the measure. Measure of angle 1 equals the measure of angle 2. That's by definition of congruent angles. Now, why does angle ABC consist of the sum of angle 1 and 2? What are you doing? You're just taking and adding two angles to get a bigger angle. That's called your angle addition postulate. Okay, now you already got angle 1 equals angle 2, so we're going to trade the 2 for a, look, angle 1 equals angle 2. Look where we're headed. We're trying to get to ABC equals twice the measure of angle 1. So since it says angle 1 and 2 are equal, can't we trade angle 2 for an angle 1? Now let's do it. That's what we're doing, making a substitution for it. Okay, so now the measure of angle ABC, and I'm sorry about this. This is not the correct wording here. Did I change it? Or does it still say distributive there? I don't like that. So let's remove it. That equals 2 times the measure of angle 1 by, what do you do when you add like terms or add two things? Just simplify is fine with me. That's just, I think you think of distributive, you're going to think of the parentheses, right? Okay, so I'm multiplying it through. Well, thank you for your patience and attention. Try to do some of the rest of the proofs, and we're going to discuss some more tomorrow and get ready for our next quiz. Wednesday.